Have you ever pondered over the concept of nothingness? Imagine a world without dimensions, where length, width, and depth are non-existent. A realm that doesn't take up any space, yet it's the foundation of all that exists in the universe. Welcome to the fascinating world of zero-dimensionality. Zero-dimensionality isn't as arcane as it sounds, it's simply the realm of points. Yes, those tiny dots you see on a piece of paper or the pixels on your screen. A point in its purest form lacks any physical extension or dimension. It's the simplest and most fundamental mathematical abstraction. Consider a line drawn on a piece of paper. It seems to have length and perhaps some width if you squint hard enough. But what if you could zoom in, way in, until that line becomes a series of individual points, each without dimension, yet collectively forming the line you see? That's zero-dimensionality for you. The philosophy of mathematics teems with paradoxes and dilemmas that have puzzled scholars for centuries. Take Zeno's paradox, for instance. It posits that motion is an illusion because to reach a destination, one must first reach the halfway point, then the halfway point of the remaining distance, and so on ad infinitum. This suggests an infinite number of points, each zero-dimensional, yet together forming a finite distance. The concept of zero-dimensionality also underpins the notion of continuity in mathematics. A curve, for instance, appears smooth and continuous, but it's actually composed of an infinite number of individual points. This paradox raises questions about the foundation of the axioms that define a point and how they relate to other axioms in the construction of mathematics. The point is a mathematical idealization, a purely conceptual entity. But what's its relationship with physical reality? Does a point in physical reality, like a subatomic particle, truly have zero dimensions? Or is it merely a convenient abstraction, a mental construct that enables us to grapple with complex mathematical concepts? Intuitionist philosophers question the validity of using points as real entities, advocating for more concrete mathematical constructions. They argue that mathematics should be grounded in the intuitive understanding of numbers and their relationships, rather than abstract entities like points. Different geometrical systems, such as Euclidean and non-Euclidean, address the concept of the point in varied ways, further complicating its understanding. The philosophy of mathematics also grapples with mathematical Platonism, the idea that points, like real numbers, exist objectively, independent of our understanding or perception. To summarize, zero-dimensionality is the concept of points, the most fundamental mathematical abstraction. It's integral to paradoxes like Zeno's, and central to the notion of continuity in mathematics. The philosophy of mathematics questions the foundations of the axioms that define a point, its relationship with physical reality, and its role in different geometrical systems. Whether points are real or merely mental constructs remains a hotly debated topic. So, the next time you see a dot on a page or a pixel on a screen, remember, you're staring into the abyss of zero-dimensionality, a world without dimensions, yet the foundation of all that exists. Isn't that something to ponder?